These videos will focus on inverse of matrix, and particularly we're going to look at the 2 by 2 matrix. The inverse of a square matrix A, denoted by A raised to the power -1, which is the symbol for inverse matrix, is given by, so if A is equals to these entries A, B, C, D, then A inverse with this notation is equals to 1 over determinant of A, matrix A, and then multiplied by these entries of the matrix A inverse. So if you take a look at these entries here and these entries, you discover that for particularly A and D, you see that there's an exchange. So where you have A in matrix A, in A inverse you have D, and where D, where you have the entry A22, which is D, position D, in the A inverse you have A, and then you discover that B and C in A inverse is they have the minus sign attached to them, minus B minus C. So the note here is that there's exchange of A and D, which is D comes here, A comes here in A inverse, which is what we have here, and then there's negation of B and C, entries B and C, which is what you're seeing here, minus B minus C. So in a nutshell, to get the inverse of the matrix, just exchange the entries A11 and A22, which is the exchange them, and then negate A12 and A21, which is these two entries, in that way. And then also you have to get determinants of the matrix A, and then you solve it like this to get your answer. So find the inverse of matrix A, 4, 2, B, 4, 2, 5, 2, 8. So matrix A, the inverse will be given. Inverse of matrix A will be 1 over determinant of A over 3 minus 5 minus 2, 4. You change these two parts. This will go here, this will come here. Then you negate this and this. So let's get the determinant of A. Let's say got determinant of matrix A is equals to 4 times 3 minus 5 times 2. That's 12 minus 10, which is equals to 2. So A inverse equals to 1 over 2, 3 minus 2 minus 5, 4. So now 1 over 2 is a scalar, so it's going to multiply all the entries in the bracket. So we're going to have 3, 1 over 2 times 2 will give us 2 over 2. This will give us minus 5 over 2, minus 2 over 2, and 4 over 2, which will be equal to equals to 3 over 2 minus 5 over 2, minus 2 over 2 is minus 1, 4 over 2 is 2. If P is equals to 2, 1 minus 3, 1, find what is P inverse. P inverse is equals to 1 over determinant of P, not E, determinant of P, 1 over determinant of P Then we exchange this to 1 minus, this will give us minus minus. We are going to negate these two sides, minus 1 and here the 2. So, minus times minus will give us plus. But determinant P, which cannot be written in this way, was remember you are not taking the determinants of this part, is the determinant of matrix P, which gives us 2 times 1 times 1 minus 3 times 1. So this is 2 minus 2 times minus 1 will give us minus 3. Yes, 2 plus 3 is equal to 5. So P inverse is equals to 1 over 5 over 1 over 5 over 1 minus 1 minus x minus is plus, that's 3 and 2. You can leave your answer like this, or if you expand and multiplying the matrix by the scalar, you have this 1 over 5, 3 over 5, minus 1 over 5, and 2 over 5. Either this or this is correct. Now, shall we find the inverse of 8 7 minus 4 and 6? We are asked to look for the inverse of this matrix. The inverse of 8 minus 4 and 7 6 equals to 1 over determinant over 6 minus times minus 7 give us 7, minus times minus 4 give us 4, and we have the 8. But determinant of matrix 8 minus 7 minus 4 6 equals to 8 times 6 minus 4 times minus 7. 8 times 6 is 48 minus times minus is plus 4 times 7 28. But 8 minus 28 is equals to 20. So inverse of 8 minus 4 minus 7 6 is equals to 1 over 20 6 4 7 8. Question 6 over 20 4 over 20 7 over 20 and 8 over 20. 6 over 20, 2 into 6 gives us 3, that's 3 over 10, 1 over 5, 7 over 20, and 4 over 10, 2 over 5. 2 over 5. The matrix P has an inverse P inverse equals to P inverse equals to 1 0 minus 3 1. Find P. To get P, we need to take the inverse of P inverse. So taking inverse E inverse. So, for indices, and then the P minus 1 minus 1 minus 1 times minus 1 gives P raised to 1, which is equal to P. So this means that we're going to take the inverse of this matrix. So P inverse equals 1 over determinant of P inverse multiplied by 1, 3, 0, 1. But determinant of P inverse equals to 1 times 1 minus 3 times 0. Which is 1 minus 2 times 0 is 0 is equals to 1. So P inverse is equals to 1 over 1, 0, 3, 1. 1 over 1 is 1, and 1 multiplying each of the entries in the matrix will give us the same value that you have as entries in the matrix. So you're going to have the final answer to be 1, 0, 3, 1. We're giving that A 1, 3, 2, 1, B minus 3, 1, 2, 1. A find A inverse. So A inverse is 1 over determinant A over 4 minus 3 minus 3, 1, 1. Determinant of A is equals to 1 times 4 minus 2 times 3, 4 minus 6 minus 2. A inverse 1 minus 1 over 2, 4 minus 3 minus 2, 1. Minus 4 over 2 minus 2 over 2 minus minus 3 over 2 minus 1 over 2. Minus 1 over 2 gives us minus 1 minus 2 minus 2 gives minus 1, 3 over 2 minus 1 over 2. Says it's 1 minus plus 1 minus times minus gives us plus minus 1 so it gives us plus here. So B inverse, that's my figure of 1, my figure 2. B inverse equals to 1 over determinant of B 1, 4 minus 2 minus 1 minus 3. Determinant of B is equals to minus 3 times 4 minus 2 times 1 minus 12 minus 2 minus 14. The B inverse is minus 1 over 14, 4 minus 1 minus 2 minus 2. So we're going to have minus 4 over 14 minus times minus 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 2 over 14 minus minus 1 over 14 and minus 3 over 14. Minus 4 over 14 will give us 24 over 14. I'll give us minus 2 over 7. And here give us 1 over 7. 1 over 7. Minus x minus plus 1 over 14. And here 3 over 14. That's number figure 2. We're going to do D here. B. It says use your results in A to find BA as the inverse of BA. We say by inverse property, AB inverse equals to B inverse A inverse. We're not looking for AB inverse, rather we're looking for BA inverse. Plus BA inverse equals to A inverse B inverse. So what that implies is that from this property, we're going to multiply A inverse matrix with B inverse matrix. Yeah. So A inverse B inverse equals to A inverse is minus 2, 1, 3 over 2, minus 1 over 2, and B inverse is equals to minus 2 over 7, 1 over 7, 1 over 14, 1 over 14, and 3 over 14, 3 over 14. I will come over here. Is equals to minus 2 times minus 2 over 7 will give us minus 2, minus 2 times minus 2 over 7 will give us 4 over 7, and 1 times 1 over 14 will give us plus 1 over 14. Minus 2 times 1 over 7 will give us minus 2 over 7, and 1 times 3 over 14 will give us plus 3 over 14. 3 over 2 times minus 2 over 7 will give us minus 6 over 14. Minus 6 over 14 plus minus 1 over 2 times 1 over 14 will give us minus 1 over 28. So minus 1 over 28. 3 over 2 times 1 over 7. 3 over 2 times 1 over 7, that's 3 over 14. 3 over 14. And minus 1 over 2 times 3 over 14 will give us minus 3 over 28. So I'm going to do this here. 4 over 7 plus 1 over 14 LCM is 14. 14 to 7, 2. 2 times 4, 8 plus 1. That's 9 over 14. Use 9 over 14. 9 over 14. Minus 2 over 7. Minus 2 over 7. Plus 3 over 14. 14 minus 4 plus 3. That's equals to minus 1 over 14. Minus 1 over 14. Minus 6 over 14. Minus 6 over 14. Minus 1 over 28. 28. 14, 2. Minus 12 minus 1. That's minus 13 over 28. Minus 13 over 28. Now 3 over 14. 3 over 14 minus 3 over 28. 28. The unit of 14 is 2. That's 6 minus 3. That's 3 over 28. 28. So we're going to look for define matrix T if S is equal to I, where S is minus 1, 1, 1, minus 2, and I is the density matrix. So we want to use relation to get the matrix T. But recall that for any matrix A is inverse A minus 1, A minus 1 is equals to identity matrix. So what that means that we multiply matrix A with its inverse, we will have an identity matrix. So this also implies that T. So this implies that T is the inverse of S. So if S is equals to minus 1, 1, and then 1 minus 2, then S inverse equals to 1 over determinant of S minus 2 minus 1 minus 1 minus 1. That's determinant of S is equals to minus 1 times minus 2 minus 1 times 1 is 2 minus 1, which is equals to 1. S inverse equals to 1 over 1 minus 2 minus 1 minus 1 minus 1. 1 over 1 is equals to 1. This is equals to so S inverse, which is equals to C. So equals to C equals to minus 2 minus 1 minus 1 minus 1. Find the value of x for which the matrix B has no inverse. The matrix B has no inverse implies that the determinant of matrix B is equal to 0. So in that case, I'm going to represent it this way. x minus 2, 1, 2, x minus 3 is equal to 0. So we don't look for the determinants of this matrix. This will give us x minus 2, x minus 3, minus 1 times 2 is equal to 0. So x times x will give us x squared, x times minus 3x minus 2x, minus 2 times minus plus, minus 2 times minus 3 will give us plus 6, minus 2 so this is 0, x squared minus 5x plus 6 minus 2 is equal to 0, x squared minus 5x plus 4 is 0. So the question says we should find the value of x. So we can't stop here. So let's proceed to factorizing. The two factors. So this will give us 4x squared. So two factors of x, where this is plus, this multiplied by this. So factors of x, 4x squared. When multiplied, will give us 4x squared, and when added, will give us minus 5x, will give us minus 4x and minus x. So minus 4x times minus x will give us minus times minus plus 4x squared minus 4x minus x will give us minus 5x. X squared minus 4x minus x plus 4 is equal to 0. So x squared minus 4x and minus x plus 4 is equal to 0. X is common, so we factor it out and give us x minus 4 and minus x minus 1 give us x minus 4 equals to 0. This gives us x minus 1 and x minus 4 equals to 0. So either x minus 1 is equal to 0, which implies that x equals to 1, or x minus 4 is equal to 0, which also implies that x is equals to 4. Therefore, the values of x are 1, 4. Since the values of x are 1 and 4, that means so here's what the values, that's values of x.